Today we are going to discuss an important concept in NumPy called fancy indexing. Fancy indexing is an advanced indexing technique in the NumPy library that allows users to access, rearrange, or modify multiple elements of an array using arrays or lists of indexes instead of simple integer positions or slices. It provides a powerful and flexible way to extract specific elements from one-dimensional, two-dimensional, or multi-dimensional arrays efficiently. Unlike ordinary indexing, which retrieves elements one at a time or through continuous slices, fancy indexing enables the selection of elements located at arbitrary positions within an array. This feature is widely used in data science, machine learning, scientific computing, image processing, and numerical analysis because it simplifies complex data manipulation tasks while improving code readability and execution efficiency. Fancy indexing is particularly useful when working with large datasets where specific rows, columns, or individual elements need to be selected based on predefined index values. In NumPy, arrays are the primary data structures used for storing numerical data. Standard indexing retrieves elements using a single integer position, while slicing retrieves continuous ranges of elements. However, many practical applications require selecting elements that are not adjacent. Fancy indexing addresses this limitation by allowing the programmer to pass a list or NumPy array containing multiple index values. NumPy then returns a new array containing the selected elements in the specified order. For example, if an array contains the values 10, 20, 30, 40, 50, 60, selecting the indices 30, 2, 5 returns 10, 30, 60. This ability to retrieve non-consecutive elements makes fancy indexing highly efficient for filtering, sampling, and rearranging data. Fancy indexing is equally powerful when applied to two-dimensional arrays. In matrix operations, users often need to retrieve specific rows, columns, or individual elements located at different positions. Using row index arrays, NumPy can extract multiple rows simultaneously. Similarly, column index arrays allow the selection of multiple columns in any desired order. By combining row and column index arrays, users can retrieve specific elements from different locations within a matrix. This functionality greatly simplifies matrix manipulation compared to writing multiple nested loops. It is especially valuable when working with tabular datasets where analysts frequently need to select particular observations or variables for further analysis. Another important application of fancy indexing involves Boolean indexing, which is closely related to advanced indexing techniques. Boolean indexing uses arrays containing true and false values to select elements that satisfy specific conditions. Instead of specifying numerical indices directly, users create logical expressions that evaluate each element of the array. Elements corresponding to true values are selected, while those corresponding to false values are ignored. For example, a condition can be used to retrieve all values greater than a specified threshold, all negative numbers, or all even values within an array. Boolean indexing is widely used in data preprocessing, cleaning datasets, removing missing values, filtering records, and selecting observations based on multiple conditions. Since it operates directly on logical conditions, Boolean indexing often produces shorter and more readable code than conventional looping techniques. Fancy indexing offers several important advantages in numerical computing and data analysis. One major advantage is flexibility. as users can access elements located anywhere in an array without requiring continuous ranges. Fancy indexing also enhances productivity, enabling programmers to manipulate large datasets efficiently using concise code. Because NumPy performs these operations internally using optimized C implementations, fancy indexing often executes much faster than equivalent Python loops. Furthermore, it supports easy rearrangement of rows and columns, repeated element selection, random sampling, and customized extraction of data for statistical analysis or machine learning applications. Fancy indexing plays a significant role in data science and machine learning. During data pre-processing, analysts often divide datasets into training and testing subsets using randomly generated index arrays. Machine learning algorithms may require selecting specific features or observations from large datasets based on predefined criteria. Image processing applications use fancy indexing to manipulate pixels, crop images, apply masks, and extract regions of interest. In scientific computing, researchers use advanced indexing to analyze simulation results, perform matrix computations, and process multidimensional experimental data.